The first beetle population that we're going to observe lives on Easter Island. Easter Island is a remote volcanic island located over 2,000 miles off the west coast of South America. This island is best known for huge stone statues that early inhabitants carved from volcanic rock. The beetle population on Easter Island is found on the far eastern tip of the island, where iron-rich volcanic ash makes the ground reddish-orange, as you can see in the right-hand side of this satellite image. Here we are on Easter Island, ready to start observing our first population of beetles. As with all of the islands we're going to visit in this activity, the environment where the beetles live is predominantly red. This is something to keep in mind as you consider the different factors that impact beetle survival and the various microevolutionary processes that they experience on the different islands we'll study. This is the first generation of beetles that we're going to observe on Easter Island. Remember, each beetle is represented by two beads because they're diploid. And here I've got the beetles organized by their genotypes: homozygous dominant, heterozygous, and homozygous recessive. At this point, you should pause the video, go to your data table for Easter Island, and record your data for generation 1, looking at the different genotypes, the number of each allele, and then calculate the allele frequencies. On each island that we study, the beetles are going to be subject to a different microevolutionary process. On Easter Island, there is a predator that eats the beetles that are most visible in the environment. If you recall from the introduction video, red is completely dominant over yellow. So these beetles would all be red, these beetles would also be red in appearance, and these beetles would be yellow. Because they're living in a red environment, these yellow beetles are going to be very, very visible to predators. I am the fearsome predator. Nom 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 nom. Nom 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 nom. Oh, one more. Nom 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 nom. Since all of these beetles are red in appearance, they're better camouflaged and blended into their environment better, so the predator didn't see them. So these are the beetles that will survive and go into the mating bag as the remaining gene pool to create the next generation. Here we have generation 2 of the beetles on Easter Island. These are the offspring of the surviving beetles from generation 1. At this point, you should pause the video and collect your data for the different genotypes, the number of each allele, and calculate the allele frequencies for generation 2 on Easter Island. Once again, the predator comes along and eats the beetles that are most visible and least camouflaged in their environment. These surviving beetles from generation 2 are the ones that will go into the mating bag and produce the offspring that will be generation 3. Here we have the beetles in generation 3. So these are the offspring of the surviving beetles from generation 2. At this point, you should pause the video and collect your data for the different genotypes, alleles, and calculate the allele frequencies for generation 3. You know what happens next. Along comes the predator and eats any beetles that are easily visible in their environment. Those are the only ones it can find. So these beetles are the ones that are left to go into the mating bag and have the babies that will become generation 4. Here are the beetles in generation 4 on Easter Island. So these are the offspring of the survivors from generation 3. You might notice that the beetle population, the total number of beetles, might change from one generation to another, and that's okay. Just like every set of human parents doesn't have the same number of babies, each set of beetle parents can have different numbers of babies too, and if there are plenty of resources, they might have more babies. The main thing we want to focus on is how many of each genotype and how many of each allele. So at this point, you should pause the video, count the number of each genotype, the number of each allele, and calculate the allele frequencies. When you've completed the data table for all 4 generations of beetles on Easter Island, follow the directions on the Easter Island assignment to create a graph of the allele frequencies over time and answer the analysis questions about what's happening on this island.